To begin with, let us think why AutoML has become so popular recently. There are several reasons to that. If we talk about the volumes of data gathered in companies and the number of tasks solved either in companies or in academia, this number is by a factor of magnitude that more than the number of experts or specialists that we receive from educational institutions. Therefore, it increases the personnel hunger and slows down the ML development. And we can see that data are changing in the world, and the input data in the models are not like the training data sets, and therefore the profile that we have as the output of the model is lower and lower, and at some point of time it can be negative even. Therefore, we need to retrain the model, but to have the same data scientists focusing on retraining the model every month is not possible. We want models to retrain automatically. And here, AutoML can help us. Apart from that, a frequent situation is when there is a single business task that is composed of a huge number of smaller tasks or subtasks of machine learning that are solved on their specific data. And again, solving them manually will take a lot of time because there can be dozens or hundreds of tasks. And again, AutoML can help us a lot because it can work 24/7 without holidays, weekends, and naturally the pay. But obviously, we will have to invest into the computing resources. And talking about a specific task, a specific ML business task, here we can say that we always see certain symbiosis between a data scientist and AutoML, because when AutoML computes a specific scene, a data scientist has a pretty good set of time or amount of time vacated to understand whether they selected the target matrix, target variable and validation scheme correctly, whether they are solving the correct task or the task should be set differently, and so on and so forth. And all these options can be implemented with the help of the symbiosis of data scientists and AutoML, and therefore speeding up the ML practices introduction into business processes. And as we generally understand that AutoML is pretty useful to business, we go online to GitHub to see the packages, the batches that implement these solutions, and we understand that there are a lot of AutoML solutions. What should we do in this context, and how should we understand what particular solution should we take to get the optimal quality for a specific task, or to satisfy some other business requirements that we have in a specific task? And that is the question that we are going to try to answer with my colleague Alexei A.Natekin, head of SAI community and Data Souls company, in the presentation that is called Open Source AutoML Benchmark. Please pay attention to your screens. So, colleagues, hello, my name is Alexander Ryzhkov, and I'm head of AutoML project in AI laboratory of Sber. And Alexei A.Natekin, the leader of ODS AI and Data Cells, is here with me today. And today we're going to talk to you about open source AutoML benchmark. To begin with, we will talk about what AutoML is, then we will speak about the difference between benchmark and regular competitions, then we will see how we can compare different AutoML solutions and what is under the boot of our benchmark, about the results that we have received and how we can contribute to our benchmark, and we will make certain conclusions. So let's not beat about the bush. AutoML is considered in different meanings of the words. Narrowly speaking, that is a certain tool that allows to choose the optimal structure of ML model to solve a particular task. But very often AutoML is considered in a broad sense of this word. That is a technology or framework that is trying to automate practically all ML modeling pipeline, including data collection, data preparation, engineering, model building, parameters optimization, model validation, and report generation, and even model deploy and its inference in production environment. There are various AutoML solutions, and they can be broken down into open source solutions like our Light AutoML and H2O AutoML from H2O, AutoGluon from Amazon, Fedot from ITMO, Teapot, Autoscaler, and this list is endless. And there can be proprietary solutions that you will have to pay for the license, and that is H2O Driverless AI, Google Cloud AutoML, IBM Auto AI from IBM, Microsoft Azure from Microsoft, and so on. And what is the difference between the benchmark and regular ML competition? The benchmark methodology is much more complicated than regular ML competition. If you don't believe that, let's compare them. For the regular ML competition, we have several one metrics on the leaderboard, and there is a single task and a single specific data set. It is pretty easy to have winners on the single score, and the solutions are mainly useful for this particular competition, and they are rarely suitable for production because they are either difficult or they use some specific features of a particular competition. And importantly, the number of solutions that we receive is much more than the number of articles that we can publish based on this competition. As for the AutoML benchmarks, in benchmarks, we as a rule have multiple metrics and options of calculating the results on different tasks. There are multiple tasks and multiple data sets, and there is no clear understanding of who has won, because depending on how we sort and calculate the decisions, the solutions, winners can be different, and the solutions that we generate are different, and they allow to solve different tasks from data science. The solutions are mainly some tools that allow to send the solution to the production, and there are many more articles than solutions. And when we talk about the benchmark, it's important to understand that reproducibility is a critical factor for the benchmarks. And we have to understand that evaluation has to be public, transparent, and open for different experiments 24/7. And on the other hand, the metrics, scores, and methodologies of metrics calculation have to be open as well, so that people can trust it. And important to understand is that reproducibility is an important topic today for the whole scholarly community, and we can see just some of the articles. And the leftmost article is by a parallel group from our lab that deals with recommender systems, and it was the only article from Russia that was adopted and accepted by A-level conference this year. If we try to compare AutoML solutions, we can say that there are several benchmarks, and one of them is a benchmark on the basis of OpenML datasets. What is there inside it. There are 39 binary and multi-class data sets at openml.org, and there are 17 AutoML solutions and 4 baseline algorithms for comparison. There are several run configurations, both local, Docker, and based on AWS, and there are different resource constraints given for calculation. But at the same time, there are ways and paths of improvement for this benchmark. It would be great to see regular full runs in the benchmark because the last one is dated 2019. There were only 4 AutoMLs and 4 baselines of old releases, and now the run is underway, but it has lasted for almost a year. And we would be also happy to see regression data sets, and we would also like to say that if splits and data sets are open for everyone, then it can be a potential overfitting thing for specific data. And we would be happy to see more metrics. Currently, AUC for binary and multi-class are used. To adjust all these things, to amend all these things, we are implementing our AutoML benchmark on the basis of ODS.ai. And you can see a QR code and screenshot of the web page that you can use to get to this benchmark. Yes, thank you, Alexander. We will be happy to see you all in our benchmark, and I will give you some more detail about it. This benchmark looks like an ordinary competition, so you go there, and at any time of day or night, you can send your solution. And this competition is coded, so you send your code that can be launched at any groups of data sets, independently of you. To have academic continuity, we designed this benchmark fully competitive to OpenML, but it can expand it. The first and most important thing about this benchmark, like competitions with their mechanics, there are check phases and public and private dashboards, but in this competition, you know that AutoML is a pretty hungry thing. There are different phases. So first, you launch your solution, and it is going through the check phase, and you receive your tool for the debugging. Then, at any time, live leaderboard is accessible, and there your solution can have real-time updates on a subset of data sets, and you receive live feedback for your solution in any convenient way. And the official release of the leaderboard of the benchmark is the so-called large leaderboard. And here we can have the absolute run that we launch on average once a month. And the results of this large run and large leaderboard are official benchmark leaderboard as of the last moment, so when this result, when the score was calculated. As for the data set, it is obvious that we started with the existing data sets, and these data sets are comprised of tables from 500 to 100,000 rows, and there are not many 5,000 features there after OHE. There are no synthetics, there are no subsets in these data sets. Everything is clear and transparent. Data sets are unique. In OpenML, there is only the task of classification with at least 2 classes, and the main important majority-minority class ratio should be at least 1 to 20, and there has to be at least 20 samples per class. And I believe the most important achievement of this release of this group of data sets is that OpenML has come up with a basic check on leakages, and their task and their data set can be solved with a super easy method, linear combination or prediction, or the tree with depth 1.
Apart from that, we have a group of data sets. The most important is the one from community. We look forward to your data sets, not just classification data sets, but with the regression tasks or subtasks with specific metrics closer to reality and what real business requires. Also, as you know, in real life, most of validation is out of time. So we use yesterday's data to learn, and we predict data for tomorrow. If it's applicable, welcome. We have that data set community, and we are ready to invite new members. But data should be in a table, and later on there comes industrial and financial data sets, again for real problems and compatible with other groups. Plus, the number of groups can grow. So, if you have a lot of data sets, or if you want to start a group, send it to us, and we will have a discussion. So maybe then, at the end of the day, we have a separate one. Also, different MLP and CV, we should leave them for the future, because we need to expand the benchmark. About computation resource constraints, your solutions should meet the super simple requirements, like for computer gain contents, for virtual CPUs, 12 gigas of memory. As solutions are very simple, the algorithm should scout a lot of models. So the archive size is of 50 megabytes. With all libraries for all images, it's not limited. You can take any image from Docker Hub. Also, the train test would be 9 to 1 or 90 to 10 and 10 runs, but 70 to 30. 70% is test and 30% is track. And there would be 1 hour runtime per data set. Well, no one would spend more than an hour. But you know, we need to know that on AutoML, you are given 10 hours. Again, you will have common tool-based lines available on our GitHub. How will we compare solutions? Because it's the most interesting thing that makes benchmark from AutoML contests. Before, it was all chaotic metrics, rock, aux, for baselines, you need prediction tools. But we would build an anonymous statistics that answers, which gives one and the same answer, a linear model, regression, a linear model. For each class, a linear model. You can find this baseline on our GitHub. And of course, for different data sets, you have different metrics, ROC-AUG for binary classification, ROC-AUG1 for multi-class, RMSE for regression. And how will we calculate it? We will calculate the score against a linear baseline. So we will be able to interpret on how and every solution is different from standard statistics in percentage. And you also don't need to break leaderboards. Quite often you have a situation when you need to show scores from different data sets on leaderboard. You don't need to reshuffle the leaderboard. How do we calculate it? The leaderboard score. We calculate a metric for the dataset first. Then you calculate the score compared to the metric baseline and the total score for a group of dataset. It's more important that it's a group. It's an average dataset score. However, although we have aggregated scores in leaderboards, we will have detailed metrics for every dataset. They will be shown in the team profile and also logs in logs for the check phase. But also there will be a large leaderboard. It will be available for downloading and analysis, visualizing and writing articles anytime. Well, if you see the large leaderboard, you see a lot of numbers, but you can download the numbers and test yourself what solutions work and on what data sets. And you will have extra opportunities to sort it by the highest number of wins. Those numbers, people who show presentations in present port, like again, so we will see if the new data sets would win over a standard statistics. You see the solutions which are highlighted in gold, silver, and bronze, and you see that for different data sets, different tools work. You don't have any super winner that would be best for every data set. Every tool for any data set could be better. So you don't have any free lunch. We know that not only about machine learning algorithm, but we also see the it works for pipelines of AutoML tool. Quite often they are very close to each other, and they don't. The score is very close. So if one has higher score, it doesn't say that it's much better than the average. It happens very rarely, and quite rarely modern AutoML tool that you can download now, that they are outperformed by the naive statistics. So we see the scores we get from all AutoML datasets, and they are close to each other. It's not possible to say that you have one tool which is really outperforming all others. They are all cool. They all have good features, but it shows that the rating is like this for this group with you see the situation with autogluon, H2O, and light AutoML being the top three. Is the score significant? No. We need more dataset groups, and we need your datasets. To go deeper, if you have the peer comparisons, it shows that, sorry, these differences for AutoML datasets are not, the difference is not big. So it's not possible to say what's the best tool in the world. What else can we know from the preliminary results? Configs is something very important. We began with separate run for AutoGluon, taking it in its original form from GitHub, and you can also configure it and improve the results by 1.5%. So during the previous run, the latest version was shown. If you know how to adjust things in AutoML, the results can be much better. Another thing which is important, you need to highlight the difference. Well, if you use the fast mode, the result for time utilization and setups of light AutoML would not be much inferior. So you can have an auto run which would be a little bit worse, but much faster. So remember that configs and extra AutoML features are important, which is normally not assessed by benchmarks. We are waiting for you. We want your data sets to be added to our community group. And to summarize, what happens with AutoML benchmark we already launched. So Alexander was quite correct that it's not easy to prepare benchmarks as normal contests, but I can tell you for sure, AutoML is something good. It allows you to craft a quick start basis line. You spend an hour and you get very close to solving your task. There are a lot of classy tools that are replaceable if you don't like to work with GVM or Java. Then you can use something different, and different tools are continuously updated and improved. And we saw it during the first public run. Please follow benchmarks. The results are updated, and we hope that they will improve. If you compare, it's difficult to compare AutoML, different AutoML products. So I hope you don't believe there is free lunch. But at AutoML, you can use it from different angles, from the point of view of academicians. Academicians want to write articles on simple data sets. In industry, it's interesting to test AutoML for very large data sets. Some would like to see whether it's simple. So it's not possible to compare data sets at a different benchmark. We believe the AutoML benchmark would be helpful not just for the community, but for the entire industry, because, well, 24/7 you can get available information on what's AutoML for a large range of tasks. And this benchmark contributes to reproducibility and transparency, but it's also scalable. So if you have ideas on what and should be calculated and how, what additional protocols should be added, you're welcome. We are waiting for you. We would like to further improve that benchmark for the entire big science. A little bit of philosophy for the future. In the future, we expect that people living in different worlds, auto line series, and others, so they can also be part of other benchmarks where you would be able to see data sets, download solutions, and write an article. Once again, you are welcome. We are waiting for your data sets, and good luck with continuation of AI journey. Okay, I think it was a really exciting presentation. I would like to check it with you, how a new person can take part in this benchmark and craft his own solution. There are a number of recipes. So we compared baselines. So they are from popular tools. They are all available at GitHub. Take one open baseline to see the way it works and what can be improved. Maybe you will learn how to match configs at AutoML. Or maybe if you want to dive deeper, at the moment, Alexander and his team on AutoML, they have an open course on AutoML, and they analyze what's inside a llama, certainly not a biological llama. So maybe this course would help you how to start from scratch. But normally you start with a baseline. It's just one interface that makes access to an ambitious thing like a benchmark on AutoML easier. Thank you. I think that our participants would find the way to join your benchmark.